In this lesson, we are going to go over direct and inverse variation. I put a K up at the top as our little icon here, and we'll talk about how that's going to be important as we go through. So our objectives are to understand direct and inverse variation, and then we'll solve direct and inverse variation problems. So when we're talking about variation, we're dealing with relationships where constants are involved. So typically, we use K to express the constant of variation. Okay, so when we're solving problems, what we're typically given is information to find what K is. And then once we have that, we can use the given information to find out whatever it's asking us to do using the K value that we just found. Okay, we'll talk about that a little bit more when we get to the problems. But first, let's talk about direct variation. It's when two variables are directly related. Okay, so for instance, the perimeter of a square is P is equal to 4 times S. Okay, so what this is looking at, one way you can think of it is that as the length of the sides increases, so does the perimeter. This also increases. Okay, so there's a direct relation there. One goes up, the other's going up. Okay, you could say the same thing. If the lengths of the sides are getting smaller, decreasing, then the perimeter would decrease as well. But when you're looking at direct variation problems, you want to start with y is equal to k times x, or whatever variables it's giving you. Okay, so if we were to say this problem, this would be y varies directly with x. Okay, and then we have k as our constant of variation. Okay, so for our example, this would be perimeter varies directly with the length of the sides. Inverse variation, we have y is equal k divided by x. Okay, so this would be y varies inversely with x, where we have k as our constant of variation. Okay, so rate speed when traveled at 100 miles. So we've got rate is equal to 100 divided by t. So notice as time increases, rate decreases. Think about that as your commute to school. So whether you're walking or you're riding a bike or you're taking the bus or driving your car, if it's taking you longer, you're probably going at a slower speed than usual. Or as time decreases, rate increases. You're rushing, you're speeding up, so you're getting there in a smaller amount of time, but your speed is increasing. Okay, so these are inversely related because as one's going up, the other's going down, or vice versa. So let's do some examples. Or actually, let's talk about steps to solve. So determine if the problem is asking about direct or inverse variation. So if it's asking about direct, you want to think multiplication. If it's talking about inverse, you want to be thinking of division. Use the given values to find k, and then what you'll do is you'll use k and the information given to answer the actual question it's asking. Now let's do some examples. Okay, so we have if k varies directly as y and x equals 42 when y equals 7, find x when y equals 10. So let's break this down. This first part is telling us there's direct variation. X varies directly as y. So we've got x is equal to k times y. The second piece of information, x equals 42 when y equals 7. Notice from the equation, if I have the value of x and I have the value of y, I can find k. So this allows us to find k. This third piece of information is we'll use k to find out what it's actually asking us to solve. Okay, so let's find k. So when x is 42, y is 7. Okay, so in order to solve for k, we divide both sides by 7. So we get k equals 6. Okay, so now what we have x is equal to 6 times y. Okay, and all I did was I plugged in 6 into k from our starting equation. So now we can use this information to answer the question, find x when y equals 10. So we're able to substitute in 10 for y and find x. So x would be 60. Okay, so the constant of variation here would be 6, or the k value that we found. Example 2. If z varies inversely as w and z equals 20 when w equals 0.4, find z when w equals 40. Again, this first sentence is telling us how they're related. This is inverse variation. So we have z is equal to k over w from that inverse variation slide. The next piece tells us how to find k. If I know z and w, I'm able to substitute those values in and find k. So we have 20 is equal to k over 0.4. To solve for k, I can multiply both sides by 0.4. And here I would get that k is equal to 0.8. Okay, so now what we have is we have z is equal to 0.8 over w squared. So our problem is asking us to find z when w equals 40. So you can plug in w equals 40 and find z. So we have z is equal to 0.8 over 40 squared. Okay, so I'm going to plug this into the calculator. Oh, there's no squared. Don't know why I put a squared there. Take the squared out. That'll come up next. Maybe I was thinking of a future problem. Okay, so we have z is equal to 0.8 divided by 40. It's just w, not w squared. So z is equal to 0.8 divided by 40. So we have 0.8 divided by 40. And this is equal to 0.02. So this is our final answer. So as you can see, we have to identify direct or inverse variation. We use a piece of information to find the constant. So we usually need to be given the values of the two variables. And then we can use the constant of variation plus the value of one of the variables to solve for the unknown. Okay, here's r squared. Z varies directly as x squared. If z equals 16 when x equals 2, find z when x equals 5. So the first statement is telling us how z and x squared are related. It's direct variation. So we have z is equal to k times x squared. Okay, if z equals 16 when 2 equals 10, so we need to find out this value that's relating the two of them. Okay, so z is 16 and then x squared. So put 2 in, put it in parentheses, and we're going to square it. So now we have 16 is equal to 4k. And we can divide both sides by 4. And this is going to give us k equals 4. Okay, k equals 4 because that's what we found, not because of the 2 squared. That was just part of it. Okay, so now we have z is equal to 4x squared. Okay, and we are supposed to find z when x equals 5. So we substitute in 5. And then we solve for z. So z is equal to 4 times 25. So z is equal to 100, and that is our final answer. Last problem, if z varies inversely as x squared and z equals 10 when x equals 2, find z when x is 4. So we have z varies inversely as x squared, so we've got a fraction going on. Z equals k over x squared. Okay, when z equals 10, x is 2, so that allows us to find k. So we have 10 is equal to k over 4, multiply both sides by 4, and we get k is equal to 40. Okay, so now what we have z is equal to 40 over x squared. Okay? And then we can use this last, really what we're trying to find z when x is 4. So we plug in z, or we plug in 4 for x squared. So we get 40 over 16, and you can keep reducing. Both are divisible by 8. So z is equal to 5 over 2. Thank you for watching. If you have any questions, feel free to reach out to me.